Hello, my name is Annaka Hansen, and for the CMSE 201 semester project, I wanted to answer the question, when is the best time to view an object in the night sky? Observational astronomy has always been one of my favorite hobbies. This is actually a time-lapse video that I took using one of my telescopes last year. I thought it would be interesting to write a program that could help amateur astronomers like myself predict which days of the year would be best to view a specific object. The goal of my code is to determine when the object will be highest above the horizon in the night sky. The celestial sphere has a coordinate system similar to Earth's latitude and longitude. Each object in the night sky can be described using right ascension and declination. Right ascension is measured in hours, minutes, and seconds, and it increases along the celestial equator. Declination has units of degrees, arc minutes, and arc seconds, and it measures the angle above or below the celestial equator. My code uses the declination values for specific objects over a period of time to predict when the object will be highest. I used the Horizon Solar System Dynamics database from NASA's Jet Propulsion Laboratory to get my declination values. The website allows users to input a specific location, date, and object, and it generates a file called an ephemeris, which includes valuable data such as the declination. In this example, I set the location to East Lansing and chose to observe Mars from January 1st, 2021 to December 31st, 2021. The generated ephemeris looks something like this. Each column represents one day in the selected time span and includes values such as the Julian date, right ascension, declination, and more. The first thing my code does is read the ephemeris file and store the components of declination in lists. Then it converts those components into degrees and plots them versus the Julian date time. This graph shows how the declination of Mars changes over the 1-year time period. The value printed at the top left is the date at which Mars reaches its highest declination. This would be the best day to view Mars within the time span because it is when it will be highest above the celestial equator and horizon. Next, I decided to fit a curve to this data so that it could be used to predict future dates when the object would be highest. To do this, I extended the time span to 2 years for my ephemeris file, and then used the SciPy curve fit function to fit a sinusoidal curve to my data. This is the final result. You'll notice that the x-axis is scaled down. I did this because curve fit doesn't work well with very small or very large numbers, so I reduced the Julian date data. Once I got the fitted curve equation, I could use it to find the declination of Mars on any given day. Here are a few lines of my code. The values for A expected, B expected, and C expected come from the curve fit parameters, and the long number is the Julian date that corresponds to June 1st in the year 2050. The code predicts that on that day, Mars will be about 9.1 degrees below the celestial equator. My code does a good job of finding the date at which an object will be highest above the celestial equator within a given time span. It can also make predictions about the object's declination at future dates, which can help astronomers locate the object more easily. However, there are some limitations to the code. In my example, I used Mars, which changes its apparent position as it and the Earth orbit around the Sun. My code does not account for things like retrograde, and would be better suited for very distant objects such as stars, nebulae, and galaxies. Although my code may not be perfectly accurate, I do find that the predictions are close enough for casual observers like myself, which was my goal in creating this project.